Good morning. This video is about the E2 elimination. So the E2 elimination is normally performed on secondary or tertiary alkyl halides. So we're going to use this substrate, which is a tertiary alkyl halide. The elimination is performed by using a strong base. Several strong bases are also strong nucleophiles, so there is a competition with other reactions, but in this case we are simply looking at the product for the E2. So this reaction normally gives you alkenes, that is what you expect to form, and generally there are several kind of products. In this case there are two products. This one is the major, and then we have the minor product. The major product is called the Zaitsev product. The minor product is called the Hoffman. So let's see what the mechanism is like. So when you do this mechanism, I would recommend that you draw the beta hydrogens. So the beta hydrogens are basically the hydrogens on the carbon next to the one bonded to the Br or to the hydrogen. So these are beta hydrogens. There are two additional beta hydrogens here. And then in the example below, I'm going to show you the other type of beta hydrogens that are present, which are on this carbon. So the mechanism is a one-step mechanism where the strong base, which is in this case is sodium methoxide, which is pretty much a not hindered kind of base. So you want to draw all the lone pairs. The oxygen is negative. So what the strong base does in the pretty much one-step mechanism is attack one of the hydrogens on the beta carbon. A double bond forms, then carbon has to have maximum 4 bonds, so the CBr bond breaks. The net result is the major product. We will see why this is the major product. So we now have a double bond. This is the CH3 plus you're gonna get Br minus, Na plus, and the corresponding alcohol, which is going to be ethanol in this case. So this is one of the products. Again, this is the major product. In the other reaction, the base will attack the other type of beta hydrogens, following the same kind of mechanism. So the base takes one of the beta hydrogens on the CH3, double bond will form, the leaving group will leave. So this gives rise to the other product in the reaction, which is this alkene here, plus the same byproducts. We got Br minus, sodium, and we have the ethanol. Now, why is this the major product? So the major product in this reaction has to do pretty much with the degree of substitution of the alkene. The alkene in this case is tri-substituted. So substitution means how many other carbons are pretty much coming off the double bond. So this is basically tri-substituted. The double bond in the other product, which is the minor, pretty much has only two substituents. The degree of substitution is linked to the stability of the alkene. So the more carbons are attached to CC double bond, the more stable the double bond is. That's why this is the major product. So this is an E2. It requires a strong base. Strong bases are either oxygen-based, and they often have a negative charge. They can be nitrogen-based, but let's say in general, you might see a negative charge. Check the slides to see a full list, but this is the actual mechanism. In the next video, I'm going to show you how do we change the stereoselectivity of the reaction by making what the minor product is the major product.